So next up, we have Professor Takashi Kubota. He's a professor at the Institute of Space and Astronautical Science at JAXA. He's also a professor of the Graduate School of Engineering at University of Tokyo. He has worked on previously on space missions like Hayabusa, and his interests are in robotics and AI for space. And now I'll leave it to Professor Kubota for the talk.
Yeah, thank you very much for introducing me. I'm sorry, so I have some trouble with connecting with the computer. So I'm Kubota, and then today I would like to talk about lunar or planetary exploration by multi-robot systems. So I'm very, very happy to come here and to present at this workshop. Okay. Oops. Just a moment. I have another trouble. Okay. Yeah, just a moment. Oops. It's a little long distance. Oops. Okay. So I talk about today 4 topics. The first one, I would like to talk about the merit of multi-robot system in lunar or planetary exploration. And then JAXA performed 2 missions by multi-robot system, asteroid exploration rovers mission and twin rovers in SLIM mission. That means the lunar exploration mission. Those are not perfect from the viewpoint of multi-robot system, but this is the first step, I think. And lastly, I would like to talk about the future mission, lunar lava tube exploration mission. I have 4 topics. Well, next slide, please. Okay, thank you very much. So I would like to firstly talk about why is multi-robot system required in space mission. So the space missions have been getting larger and larger. Then it takes a long time to develop a satellite or a spacecraft, and also the costs get higher and higher. One of the solutions, so the multi-robot system is expected to solve those problems, I think. So that's why the cooperatively exploration by multi-robot system can produce the efficient wide exploration by multi-robots, and then lead to low cost by small lightweight robots. And then it gives us the robustness by fault tolerance, I think. Do you agree with me? And then the heterogeneous multi-robot system has the robustness to unknown environment in case of the lunar or planetary exploration, and also the diversity of roles, mobility mechanisms, sensors would be a key for realizing resource effectiveness, I think. That's why the multi-robot system is expected in the field of planetary exploration, I think, and I believe. Thank you. And then, so today I will show 3 effective missions by multi-robot system. The first one is the network exploration. So scientists would like to investigate the internal structure of the asteroid or small body. So by observing the by observing the seismic waves generated by artificial impactor in the different places, and at the same time, it is possible to estimate the internal structure. Please push again. Okay, by using the impactor, then some robot can observe the seismic waves at the same time. Then it is possible to estimate or understand the internal structure. That is very important for scientists, I heard. And then second one is the wide range explorer. Sorry. Okay, thank you. Wide range exploration. Maybe I think you agree with this area. And then finally, the lunar-based construction. So many robots can build the lunar base cooperatively, I think. This is the 3 missions for multi-robot systems. Next, please, thank you. So I would like to move to the second topic, twin robot exploration in Hayabusa 2 mission. So as you know well, or as you may know, the Hayabusa 2 mission. So next, please. So the Astronautical Explorer Hayabusa 2 returned to the Earth 2020, December. And then the sample return mission is the main object. And then, so Hayabusa 2 Spectra succeeded in capturing and collecting the sample from the asteroid, as you know. Next, please. So Hayabusa 2 spacecraft has some robots. And then I talk about the asteroid exploration rover. In-situ surface observation by intelligent robot would be a promising method to explore bodies. So in planetary exploration or in asteroid exploration. But in small body, for small body, gravity acceleration on small body is so small. That's why it is easily be aware from the surface. That's why the hopping mechanism is one of the good solutions, I believe. Then, next please, thank you. And then the Hayabusa 2 has the 4 kinds of robot, small robot. So you can see the mascot. Mascot was developed by the DLR and the CNES, and then deployed on 2018 October. And then Minerva 2 was developed by the Japanese University Consortium, deployed on 2019 October. And then the JAXA developed the Minerva 2-1 with 2 robots, deployed 2018 September. So you can see the date of the deployment. So those time are so different. That's why it is not possible to estimate the internal structure, but the 4 robots could observe the surface. So I will show you next slide. So Minerva 2 has a hopping mobility and adaptation to the environment with AI, and then the robot is so small and lightweight, and with low power consumption. Just 2 watts is used for Minerva 2, and then it is possible to control or navigate the robot from the Earth. That's why the Minerva has the perfectly autonomous behavior. And then for scientific observation, stereo camera and also thermometers or other sensors are installed in Minerva 2. Next, please. So the hopping mechanism is like this. By rotating the torque inside, then it is possible to hop from the surface. Okay, next please, thank you. And then this is a flight model. Minerva 2 has a twin rover. And then so these are the cover for protect the vibration or shocking at the launch. Next, please. This slide shows the specification of Minerva 2. The weight is about 1 kilograms for each. And then each robot has a 1 DC motor for hopping. And then about the sensors, rover 1A has 4 cameras, and rover 1B has 3 cameras by some reason. And then those robots have the photodiodes, accelerometers, and the thermometers to measure the temperature of the surface and the gyros. And then about the communication, the Minerva 2 cannot communicate with the Earth directly, but it is possible to communicate with the mothership, Hayabusa 2, by just the max communication bit rate is the 3 to K bps. Okay, thank you. This is the deployment sequence. At the altitude 50 meters from the surface of the asteroid, the robot will be released at the same time, and then two robots land on the surface of the asteroid quietly, like this. The releasing velocity is about the 5 centimeters per second. And then two robots will hop and hop to capture some images, and while staying, the rover can measure the temperature of the surface, like this. Okay, please, next, please. So this slide shows the obtained image taken by Minerva 2. So the a few centimeters rock you can see. And next, please. So the while staying, another camera can take this image, obtain the image. And please, next, please. So while hopping, the robot could capture the image like this. This is captured by the wide camera. Next, please. Okay, this is also captured image. Next, please. So when the robot is staying on the surface, then it is possible to get the movie like this. And then, so processing the shade information, it is possible to construct the three-dimensional structure here. Okay, finally, I would like to show you the cooperative swarm with global localization. So next one, push please. So yeah, and by using the onboard camera on Hybsat-2 spacecraft, it is possible to construct the three-dimensional model of the asteroid like this. And then this is the map. This is so we call the global map. And then Minerva 2, two rovers could get a lot of image. The number of the image is about the 600. Then by processing these images, so the detailed map with the position of rovers is built by using SLAM technology, by using 600 image data obtained by twin robots, and also using the global map is also the image. This is the first step for multi-robot system exploration. Okay, next I would like to move to the another topic, cooperative lunar exploration by robots in SLIM mission. SLIM stands for Smart Lander for investigating moon. And then, so two robots were installed in SLIM spacecraft. Please, next, please. Thank you. So this, as you know, the SLIM spacecraft landing on the moon this year in January. And SLIM is a mission to demonstrate the technology for pinpoint soft landing on lunar or planetary surface. Okay. Oh, okay. And then so SLIM spacecraft have installed the two kinds of robots. We call the lunar excursion vehicle, the Rev 1 and Rev 2. Rev 1 is a surface explorer by hopping. And then Rev 2 is a transformable rover. Next, please. So you can see the size and the weight. Rev 1 weight is 2.1 kilogram, and Rev 2 weight is 0.25 kilograms. So light. And then the diameter is 8 centimeters ball. Okay. Next, please. So this is the sequence for our twin rovers exploration. So before landing, SLIM will release twin rovers during free fall at altitude 1.8 meters. Then two robots will perform free fall and then the touch and landing on the surface of the moon. And then the level 2 can send the data to level 1. So this robot is so small and light. That's why the level 2 could not communicate with the Earth directly. But the level 1 can communicate with the Earth directly. And level 1 can hop and also perform the posture control. Then level 1 can move in all directions. And then so we have 3 missions. The first mission is engineering demonstration on hopping mobility on the moon and direct communication and autonomous expression and also the cooperative exploration. And also, so level 1 or level 2 can swim spacecraft after landing. And also the lunar surface expression too. So 3 missions are installed in twin rovers missions. Okay, thank you. And then you can see the transformer nanorover level 2. The nickname of this robot is Soraku. And then level 2 can communicate with level 1 and also 2 cameras to observe the lunar surface and find slim spacecraft mothership. So you can see the 2 wheels and the cameras. So during cruising, the Soraku is like this, and then the ball-shaped rover, and then transformer to the wheeled rover on the right side after landing. That's why we call the transformable robot. Next, please. Okay, one push, please. Out. Oh, just a moment. I would like to show you Leo. Okay. So I'm sorry. This movie is in Japanese. So question and question. That's why we call Soraku. This is a nickname. And then this robot was developed by JAXA, Tommy Corporation, and the Sony Group Corporation, and Dosha University, and so small transformable robot like this. And then the toy technology was used to develop this robot. And then by free falling, and then after the landing, transformation is performed like this, automatically. And then 2 wheels can traverse the surface like this, and then so mobility has 2 modes, butterfly mode and core modes, like 2 rough terrain and also the sandy terrain. So this robot has 2 cameras to observe the surface and also, the slim spacecraft. So as you may know, unfortunately, some trouble attacked the slim landing, but fortunately, it is possible to communicate with slim spacecraft from the Earth. And then, next please, thank you. So this slide shows the image obtained by the level 2 Soraku, and then the data was sent to the Earth via level 1. So I call this is cooperation by 2 robots. So exactly speaking, we would like to observe or explore the surface and so in cooperative tasks, but that was not realized. But the communication system was perfect. Then we could get this data, and then we can see the condition of the stream. So this is the thruster, and then up and down like this. But so solar panels here, that's why we could communicate with this spacecraft. Okay, thank you very much. Next, please. So finally, I move to the topics on cooperative robot for rubber tube exploration. Please, next, please. So Japanese lunar spacecraft Kaguya could find some lunar caves, and then the lunar tubes may be the best place to build large-scale lunar base for future, because their interiors can protect from the dangerous space radiation and micrometeorite bombardment. And also, scientists estimated that so stable thermal condition is expected in the lava tube area. That's why this is one of the best places for future human exploration. Then next, please. So the lunar cave exploration missions have been earnestly studied in the world. JPL and ESA and MIT or other agencies and universities. Next, please. So I talk about the behavior planning for lunar cave exploration by heterogeneous multi-robot system briefly, please. So the object of a mission is to construct a map of a three-dimensional structure of the lava tube and radiation and temperature level, and also the material composition and the moisture. So the mission for the mission, tether robot takes exploration robot to the bottom of the lava cave, and the exploration robot have heterogeneous sensors, and the exploration is completed with when onboard battery runs out. It is possible to get the energy inside the lava tube. That's the first mission. I think we use the batteries only. So heterogeneous multi-robot would like to explore a wider area under the limited batteries or limited exploration period, and to find the region of interest as much as possible from the viewpoint from material composition and moisture. That is the first mission for the lava tube exploration on the moon. Okay, thank you. So I am now studying the 4 kinds of robot. So the size and the weight are so different, but please focus on onboard sensors. Of course, cameras and spectrometers for investigating the material composition and the moisture sensors. These are at least are very, very important for lava tube exploration. Next, please. So I am studying the behavior planning for efficient exploration. That's why the team-orienting problem was introduced to solve those problems. And then, please. So sorry, I have no time, so that's why the skip, please. Sorry. And then tasks and rewards are defined like this. Then, so please, next, please. And the criteria was defined like this. And then, so I would like to show you the results only. And this is the conventional method. And so by using the proposed method, the wider area can be explored like this. So the multi-robot system, and especially the heterogeneous multi-robot system, would be effective for unknown area or unknown exploration, I think. Okay, next, please. Okay, this is the performance. Next, please. Thank you. So the currently the so in Japan the moonshot project is undergoing, and then the lunar cave exploration mission is also under studying. So the in the future, in the near future, so these robots will explore and also they build the lunar base inside the rubber tube, I think. And then so today I cannot present the detail of this mission, but in exhibition some demonstration will be performed. That's why if you are interested in, please visit the exhibition hall to see the demonstration, and also the project manager will present the detail of the missions and algorithms by multiple system at the workshop on breaking swarm stereotypes on 17th May, I heard. Okay, finally, I would like to summarize my presentation. I talk about two missions, asteroid exploration and the twin rover expedition. This is the first step for a multi-robot system in Japan. And then the future missions, the lunar rubber tube and the subsurface cave under studying, and the scientists would like to explore these areas. And also this is a good candidate for human exploration. That's why multi-robot exploration is expected to be effective for the near future missions, I believe. Well, thank you very much for your kindness.
Thanks for the very interesting talk. I'm curious about the Lev 2, which is a small, very, very small robot. So how were you able to radiation harden that kind of robot? Was it affected by radiations at all? Or can you comment on that insights about the radiationing for that small robot?
Small robot?
Yeah.
The weight is just 250 grams. And then this is the payload of the stream is so small. That's why we have to make a robot smaller, lighter. That's why this robot has a primary battery only. That's why this robot could explore the surface for just 2 hours. Okay.
Thank you for your presentation, Professor. I'm curious about the design of the Minerva 2.
Minerva 2?
Because it's hopping, and there are solar panels around the surface of the robot. Do you know the destination, the terrain of the destination, that it is available to land safely? Do you know that before each hop?
Mm-hmm. Okay, so firstly, the Minerva was released at the speed 5 centimeters per second. And then the gravity is so low. That's why for example, so there is no much shock. And then after hopping, the Minerva will landing. The shock isn't so small because of the low gravity, but the surface is rough terrain, rocky or sandy. That's why I think some of parts may be broken. But today I cannot show you, but the Minerva has some pins to protect the solar panel is broken. That's why in practice mission, so Minerva could stay and explore for many days. That's why I guess the solar panel was not broken. Of course, the parallel circuit are installed. That's why the one damage is not serious.
Okay, I have another question. So thank you very much for your presentation. Considering that L-Cross measured that the temperature in the permanent shadow regions were around 26 Kelvin degrees, we can expect similar temperatures in lava tubes. How do you expect your rovers to support, to be able to deal with these very low temperatures?
26.
Kelvin degrees in the permanent shadow regions. So we expect that in the lava tubes will be very, very low temperatures. So how you are going to deal with that?
Yeah, the temperature in lava tube, scientists estimated the minus 20 or minus 60. So that's why by using the some heater system, it is possible to stay and live, I guess.
Crossing fingers.
So the the important thing is to so the temperature is stable at night. So the minus 60 is so low, but it is possible to keep the lives by using the heater. Yeah, but on the surface, so low temperature, it is not difficult to stay or keep. But the SLIM mission, SLIM spacecraft, so they took 3 times for night. It can be communicated with the Earth. So the lava tube is attractive places, but it is not easy to enter the lava tube, right? And then that's why the polar area is one of good candidate for human exploration. Yeah, thank you.
Okay, thank you very much.
Okay, thank you very much.
Thank you so much.